Our next speaker is Shelley Wiggum, and she will be talking about fire-induced grazing, promoting pollinator diversity.
Can y'all hear me okay?
Yes, ma'am.
Okay. Well, thank you for that introduction, Leslie, and thank you all for joining us today. As Leslie can attest to, I've been very excited for this presentation and symposium, so sincerely thank you for your time. Also, I want to preface that the research I'm presenting to you today has primarily been conducted in the tallgrass prairie and a bit of the cross timbers in the central Great Plains. However, my hope is that no matter what type of grassland system you work in, whether it's woodland, savanna, steppe, prairie, or even tame grass pasture lands, is that you can take these ideas back with you and even the data to not only manage your operation profitability and functionality, but certainly ecosystem function, services, and the biodiversity dependent on those ecosystems. Well, there we go. So historically temperate grasslands around the world, whether you're in Africa, Asia, Australia, South America, North America, they were created and maintained by an ecological process called Pyric herbivory, where native herbivores, both grazers and browsers, followed fire around, whether they're bison, elk, pronghorn, elephant, kangaroo, jackrabbits, or walking sticks. They followed fire around the landscape because it's palatable and nutritious. And if you can imagine, what this fire-induced herbivory created was really this diversity or this patchwork of habitat types across the landscape, whether it's local, regional, subcontinental, or even continental scales, with all these different patch types in a different state of post-fire and grazing recovery, meaning they will have different vegetation structure as well as plant species composition. And this is what wildlife species, both vertebrate and invertebrate, as well as grassland function itself, evolved with this shifting patchwork of habitat diversity across space and time. So while it'd be virtually impossible to try and implement the entire continuum of habitat types that wildlife encountered in any given place on the planet into modern day rangeland management practices or grassland management practices, what we can do is look to the extreme ends of those habitat continuums they evolved with, as well as some intermediate states, and work to implement those in our management decisions and on the ground. So no longer is it bison and walking sticks driving ecosystem patterns and processes and therefore biodiversity, say in North America. It's cattle that are managed by humans that use multiple management practices not only to drive and maintain their operation profitability and functionality, but the diversity and the ecosystem services that the lands they manage provide. So an example of rangeland management or grassland management in the Flint Hills, where I've done a lot of work, and this includes Kansas and Oklahoma. In Oklahoma, we call them the Osage Hills. You know, it's pretty typical of management anywhere in North America. There's a focus on uniform grazing distribution and forage utilization. In the Flint Hills, that looks a little bit different. We use a lot of fire, but our two typical management practices are to annually burn and graze or to never burn and graze, or minimally burn and graze anyway. And as you can see by this aerial photograph, and I'm sure you know what's running down the line here is a fence with a different manager on each side. Our management decisions don't just impact the habitat and resources on the ground, they affect the landscape. So annually burning and grazing, for example, creates landscapes dominated by warm season grasses, very little forb or wildflower diversity, and very little litter layer on the ground. Whereas minimally burning and grazing or never burning and grazing creates a landscape dominated by woody vegetation. Again, very few forbs and legumes, and excessively thick litter layer. So for our wildlife species, and today we're talking about native pollinators, and that's the research I focus on, that evolved with this entire continuum of habitat types popping up on and off across the landscape, what they're now encountering, for example, in the Flint Hills, or really most anywhere you move around in North America, are landscapes really just dominated by these extreme ends of the habitat continuum. And as you see by this red box I threw up, we're really selecting against not only most of our native pollinator species and functional groups, but even pollinator communities. So this song by Jorge Drexler, it's called Movement, and he really hits home to me that we as humans evolved with these systems too, in particular grasslands out of the savannas and the grasslands, temperate regions around the world. And we know how these ecosystem works because we lived with them. And he says, we are a species in transit. We began to migrate through the savanna, following the herd of bison, beyond the horizon to new distant lands, sniffing out that puzzling new landscape unknown. And we saw ourselves in the shadow of the bonfire. We're never still, we are nomadic. We're alive because we are in movement. It's the same with songs, birds, alphabets. If you want something to die, keep it still. And we as humans followed our habitat types, patch types around the landscape. And he just really drives home. We know this as humans. Habitat patches were in constant motion across space and time, and this process was maintained by this fire-driven herbivory. So when we go and we think about the grassland system we work in, wherever we are in North America or the world, and we think about our species of greatest conservation need or concern, especially when we think about those obligate grassland species, so prairie chickens, regal fritillaries, grass skippers, these species are boomer bust species. That is, they are metapopulation species. That is, they blink in and out across the landscape over space and time, just like the habitat they need blinks in and out across the landscape. And this holds true for migratory species too of conservation concerns, such as the monarchs. So what we're doing in managing pastures, landscapes, ecoregions, and even some subcontinents without fire, and for this uniform livestock distribution and forage utilization, we're really creating entire landscapes that are motionless in regards to the different types of habitat that us and all other wildlife evolved with, and that is it popping up across space and time. And Jorge hits it exactly. If you want something to die, make it be still. And that's what we do. We leave a lot of the habitat out of our management decisions that wildlife species need and how they move around the landscape. So here, a type of traditional management practice, you can dump whatever the traditional management practice is for the grassland system or rangeland system you work in that really selects for this uniform grazing distribution or this uniform animal distribution, uniform forage utilization. Well, this creates uniformity in habitat structure and plant species composition. And as we saw in that slide where I threw the red box up, this really selects against many of our native pollinator species. So one rangeland management practice out there that tries to mimic, Pyric herbivory or that fire-induced herbivory, both grazing and browsing, is patchburn grazing. So here what we're doing is we take a portion of a pasture and we burn it every year. Sometimes those patches are set and burned in a sequential order. Sometimes landowners decide what the fuel load is and which patch to burn off of that. But regardless, the entire pasture isn't burned, yet some of the pasture is burned. With cattle and animals, browsers such as goat, they're allowed free access to the entire pasture, and depending, for example, on the classic cattle and the grazing event length, they spend 60 to 90% of their time grazing in the year of fire patch. So what patchburn grazing does, to at least the degree possible, is it's trying to mimic at least portions of that ecological process of Pyric herbivory that grasslands and the wildlife dependent on them evolved with. A little bit of terminology: when you see PBG0, I'm talking about the year of fire patch. PBG1 is the 1 year since fire patch, and PBG2 is the 2 years since fire patch. So overall, our hypothesis is that patch burn grazing will increase pollinator diversity through an increase in feeding, breeding, brooding, and nesting habitat, which is created through this preferential grazing and recently burned patches, or that fire-induced grazing and browsing. So we're hoping to create more habitat patch types and resources on the landscape versus our traditional uniform grazing management practices. So what are some of the cattle responses when we compare patch burn grazing to the traditional uniform grazing management practice that's implemented in a given area of a landscape? Well, we find that there's no significant difference in performance responses at equivalent stocking rates. And we could do a whole talk on this information, and certainly a lot more has come out in the last 2 years, but cow body mass, cow body condition store, calf gains, stalker gains, gains are stabilized over time. There's essentially no difference between patch burn grazing and traditional management practices that select for uniform grazing distribution and forage utilization. There's also 2 really good synthesis papers, you might could argue seminal, that patch burn grazing compared to traditional management practices across whole landscapes and whole regions stabilize gains over time, as well as forage production is stabilized. And just some logistical things, patch burn grazing has decreased horn flies as well as tick infestations. For the research I've done, when we look at the habitat responses to patch burn grazing, and for example here we're comparing it to annually burning and grazing, which is one of the 2 most common types of management in the Flint Hills, we see that when we look at percent cut, percent grass cover, percent bare ground cover, and percent litter layer cover, we're creating significant diversity in those cover types within our patch burn grazing pastures as compared to, for example, annually burned and grazed. We're also producing more forbs in each patch type in patch burn grazing as compared to the traditional management practice. And I'm not showing you any data here today, but when we look at this and we go in open rangeland landscapes, we see a lot of what in the botanical world researchers and conservationists call conservation plants. I've just totally lost the words. And in the range world, we call high order plants or ice cream plants. We see these plants like blazing stars, our butterfly milkweed, our common milkweed, our native thistle species, our catclaws, sensitive briars. We see these coming back and popping back into that 2 years since fire burn. And that's essentially because the animals are spending the majority of their time in the year of fire patch and most of the rest in the 2 years or the 1 year since fire patch. And this makes a lot of sense because cattle preferentially graze native forbs. The study here I'm showing dates back to 1978 in Kansas, but this research is near 100 years old wherever you want to look at it across North America. Anywhere from 20 to 40% of the cattle diet is actually forbs and legumes, and in particular on things like our milkweeds, what we see out on these landscapes, these rangelands, is that they really preferentially graze these species when they're in bud form. They get a lot of amino acids out of these wildflowers that they simply can't get from grasses, especially warm season grasses. One of the first studies that really started looking at arthropod responses to patch burn grazing were done by Engel and others in 2008 and Doxson in 2011. And what they found when they looked at invertebrate biomass per sample and compared patch burn grazing patches, as you see here on the left, to the traditional management, which in their system was unburned and continuously grazed, there was significantly more invertebrate biomass in the patch burn grazing units, in particular in the 1 to 2 years since fire has occurred. In my research, what we found when we combined all the bees and butterfly observations across all the ranches throughout the Flint Hills, we found 222 species of bees and butterflies across all these different ranches. All 222 were found in the patch burn grazing pastures, whereas when we compare it to our annually burned and grazed pastures, we only found 77 of those species. And we have more than double the number of individual pollinators, just adding up those bees and butterflies based on our unit effort of observing and collecting. When we break it down and we look at the bee responses, 171 bee species combined across all treatments. That's probably about 20 to 25% of our native bee species, but based on the way we collected, that this was the number we came across. But what you see is we only have 45 of those bee species in our traditional management practice of annually burned and grazed, and depending on the patch type within the patch burn grazing pasture, we have different number of bee species, and we have significantly more individuals in each patch type as compared to the traditional. Same with butterflies, 51 species of butterflies across all treatments, and we didn't go into riparian or wooded areas. More than double the number of species in each patch type as compared to the traditional management, as you see by the bars. And the number of species varied depending on patch type as compared to the 25 we saw across all pastures managed with annually burning and grazing. I've also done quite a bit of telemetry work with bumblebees, queens in particular, 3 species, but 2 most all were 2 species, Bombus pennsylvanicus and Bombus fraternus, both species of great conservation concern. So what we do, we go out, we pick up a bumblebee queen when she's out foraging, we bring her back to the truck, I throw a transmitter on her, we take her back out, we drop her on her trap line, and then we'd start chasing her. And we would we'd take waypoints, and we'd say what they're doing at that waypoint. So what we found is we found a partitioning of a partitioning of feeding resources, what they use. So when they go out on nectaring trap lines or nectaring feeding bouts, so bumblebee queens and workers, primarily if they go out to forage on something, they only forage on nectar or only forage on pollen on a given trip. So what we found is these queens, regardless of species, almost across the board, collected all their nectar from milkweed species, in particular Asclepias viridis. However, when they went out on their nectaring trap lines, their pollen trap lines for pollen collecting bouts, they used most Baptisia species and penstemon species, and then when it was really windy, they would switch to other legume species that were laid lower to the ground. But there's a stark partitioning of resources used even in feeding resources. In terms of nesting habitat, other than one queen that was Aricomus, the species Bombus aricomus, that nested in a brand new burned area, all the other queens nested in areas that had high forb cover, litter layer on the ground, and they all had some type of vegetation, old vegetation they denuded so that they could crawl up to get above the vegetation to fly off. When we look at where the nests were of all of the bumblebees I'm showing you here, 9 of them nested in the 2-year since fire patch, and 2 of them nested in the 1-year since fire patch. And we didn't have any that nested in the year of fire patch or in annually burned and grazed either. However, when they went out foraging, both nectaring and pollen collecting foraging events, over 60% of their foraging for resources, for food resources, was in the year of fire patch, and a little bit over 30% were in the 1-year since fire patch. And essentially, very few foraging events occurred in the 2-year since fire patch where their nests were. And when this did occur, these 23 events are all linked to queens that were still searching for a nest and had not found their nest, had not decided on a nest yet. Other really cool thing we found with this bumblebee telemetry work, all nests were within 100 meters of a patch edge, regardless of where we captured them for tagging. And all but 2 of them were within 50 meters of patch edges coming together in the patchwork grazing pastures. So it seems as though these animals are selecting edges, and this is likely to optimize foraging efficiency and effectiveness in relation to their nesting habitat, as we see here, and their needs throughout the growing season, especially in foraging resources, as plant communities change and our patch types and our different patches change over the growing season. So grassland and woodland pollinators, what do they need? What does a monarch need? What does a regal need? What does a prairie chicken need? Well, number one, they need fire. And they need fire simply because grasslands are fire-driven ecosystems. They're disturbance-induced ecosystems. That fire and grazing-induced grazing is a driver. And as you can see from this Guyette et al. Paper from 2012, this is looking at historical fire return intervals for the contiguous United States. So certainly this isn't what we would need our fire return interval to be today based on how the landscape has changed and our management decisions. But you can see that east of the Rockies, you know, pretty much everything burned at a fairly regular basis. And when you look down here in Arkansas, it's a pretty rapid turnover. So that's the first thing we need to do. Now, once we get the fire back on the landscape, we need to implement in our management decisions and the practices on the ground, trying to create that patchy habitat. And this doesn't matter if you have a 30-acre, a 300-acre, or 3,000-acre pasture you're managing. When we can manage for different patch types, habitat, and the plant communities in them, and can make them come together, we're really helping our native pollinator as well as our vertebrate species. So here you see this on a 3,000-acre pasture. We can do this. And then once we get that fire on the ground and start managing our grazing to follow that fire, as I mentioned earlier, and several papers have shown, a lot of these conservative plant species in the botanical world, as we call them, or these high order, or these ice cream plants in the rangeland management world, they start popping back up, at least in our rangeland ecosystems. So livestock and wildlife know what they need to complete their life cycles and survive disturbances. They do it by moving through space and time to different habitat types that provide these needs, just like we do. And when we uniformly graze animals and we remove fire, we lose wildlife species and cattle production because the plant species diversity and habitat structure they need is removed from the system. And this is one reason we end up putting so many inputs, external inputs into our system to meet our livestock needs. We've remove those disturbances that actually maintain our grassland ecosystem function and the services they provide us. So that patchy fire is critical to providing different habitat types across space and time, not just for wildlife, but for livestock production. So with that, I'd like to just end with these couple of definitions. I'll give you a second to read here. So for me, when I read these definitions, I could just swap the terms and the definition would be essentially the same. So we can get conservation-based grazing and browsing management on the landscape. We can get the drivers that created and maintained our native grassland ecosystems and even improve our tame grass pasture lands into our management. We just have to make the management decisions and figure out how to get those practices on the ground and which practices we want to use. So with that, I will take any questions.
Thank you so much, Shelley. That is just, I never gets old. That's my second time hearing that presentation. It still just blows my mind. I love your research. If anyone has any questions, please enter them in the chat box. And if you're joining us on Facebook Live, please enter them in the comment section. Let's see. I have one, Shelley. How difficult was it to attach those telemetry trackers onto the queen bumblebees?
Yeah, it's actually not that difficult. You know, we just use the honeybee queen tubes, as you saw in that picture, and cut some of the mesh out, and it's just kind of like an orange pop-up, a popsicle. You just in the thing you have to watch the most is just them getting stressed out. So that's what you have to look for. And if they're just getting too stressed out, just let them go. Applying, never use super glue, because once they're on, you pull it off and they can't fly, you kill the animal. I use epoxy because if you release them, they fly, they're going to do perfectly fine with it. And if they don't fly, that epoxy hasn't dried yet. It takes a few minutes and you can just pop it off and the bee flies away. So the hard part's just chasing them because those little transmitters only have about, depending on the length of the antenna, only have about 50-meter signal strength.
That's awesome. We do have one question. Is this research published?
Some it depends on which research you're talking about, but if you want to share your name with me, I'll get to you what there is and what we're working on for sure.
I can send her contact information. And also I can include any studies to send out to all of the session registrants as well. What time of year did the fires occur? And do you think different seasonality would have a different impact on use by bees for nesting, like summer or fall fires that leave more residue?
It's a really good question. So yes, all the research shows in the central Great Plains, for example, when we're looking at tallgrass prairie, season of fire, this is a whole nother talk, but yes, the plant community changes. Important for livestock production though, especially grazing production like with cattle. The warm season grass production is not hurt. What we do see, especially with growing season burns, you know, the August, September, the mid-July through the late September burns, we just see a lot more forb production, but not at the cost of warm season grasses. And I can send all those papers out too. In terms of bumblebee nesting or just any type of nesting, that's a really good question. There's a lot of things we could speculate based on the science we do know. I'm assuming you mean brood rearing nesting, not overwintering nesting. You know, if you had, growing season or fall or winter burning and you burned off a whole huge area and you removed all the vegetation, you know, that cover is really important to that overwintering bumblebee queen for thermoregulation. But again, everything's about moderation. Don't burn everything and don't burn nothing, you know. Certainly we need to get a lot more fire on the landscape to get woody vegetation and herbaceous invasive species under control, but I can send papers out on all that.
That would be greatly appreciated, Shelley. Thank you so much. Such interesting research. That seems to be the end of the questions, so we will move to our next speaker.